At 0110 hours local time, 120 Russian fuel tankers thundered through Rostov as part of a methodical convoy headed toward Crimea, advancing past Mariupol following their predetermined path. The convoy's commanding officer believed his concealment approach was essentially flawless. Every military fuel transport had been repainted and refitted to pose as civilian cargo carriers, transporting milk products and potable water. What Russia hadn't anticipated, though, was that Ukraine possessed thorough intelligence regarding their complete route. High in the sky, a LIA-100 reconnaissance UAV orbited wordlessly over the roadway. Its optical system detected an obstacle the Russians hadn't foreseen, a deteriorating bridge that forced traffic to slow dramatically. Vehicles were forced to reduce speed and pack tightly together, forming a perfect target zone. Below, the disguised fuel column proceeded steadily toward that narrow passage. Their cargo represented far more than 10,000 tons of fuel. It was the vital supply connection sustaining Russia's military sites, weapon systems, and security network throughout Crimea. Everything seemed to be advancing without issue. Then, in just 3 minutes, the hunter turned into prey. Each transmission the LEA-100 sent to its command center broadcast electromagnetic waves, and Russia's electronic detection systems caught them. Initial signals appeared scattered and vague, but once transmissions came from the same spot repeatedly, Russian operators understood what they were seeing. To be frank, this strategic dance would establish everything that came after. Meanwhile, the convoy held its 25 miles per hour speed, drawing closer to the bottleneck. Standing 3 miles away, the Ukrainian strike group prepared to release 45 UAVs into the assault. However, 3 successive Russian protective barriers waited between them and their target. Among the most effective tools in place was the Yastreb AV, Russia's advanced counter-battery radar system. It swept the airspace constantly, detected unusual signals, and identified signal locations with accuracy. Every data burst from the Ukrainian UAV created another line of data for YTRAAV's analysis. One line wasn't enough to locate a position, but when multiple lines converged at one spot, the answer appeared instantly. That convergence point was the Ukrainian Operations Center. Just 2 minutes went by before Russian guns began their assault. Artillery shells crashed down on the command station with tremendous force, exploding violently and scarring the area around the Ukrainian team. Only then did they understand their grave mistake. Their entire operation had been transmitting from a single place, continuously, for more than 5 minutes. On today's battlefield, this amounts to marking your own position for destruction. Russia even has a formal term for this technique: reconnaissance by fire. Visual proof wasn't required. Finding, calculating, and striking, that simple progression was sufficient. YAST AV needed just signal detection, position math, and Russian artillery support to drench the area with shells. After the first strike, Ukrainian teams realized they couldn't keep sending unbroken video signals. Every transmission was pulling the noose tighter around them. So the Leica 100 switched to independent operation, powered by machine learning systems. Its onboard processor spotted the fuel convoy on its own, locked onto the target, and watched its path without needing a ground command center. The electromagnetic footprint fell dramatically. Urab AV lost the steady signal it needed for ongoing positioning. However, just as the Ukrainian group thought they'd gotten away from the counter-battery threat, something different appeared. A Russian Orlan 30 reconnaissance UAV approached from the north. Yastra AV had previously marked the suspected area. Now, the Orlan 30 was assigned to perform heat imaging and give exact coordinates within a 1.5-meter tolerance. The Ukrainian group confronted an agonizing decision: keep watching the convoy and get discovered, or stop their heat output and lose live information. They chose to fade away. Gear shut down. Power sources and broadcast equipment vanished under covers. Every operator pressed flat to the earth beneath thermal blankets and heat-blocking netting. The command center nearly erased itself from thermal detection in moments. But before reaching absolute silence, they still had to send vital targeting information to the strike group 3 miles out. Standard procedure meant direct radio contact between units, sending locations, approach paths, and strike timing. Yet, paired signals would double the electromagnetic profile, essentially placing 2 markers on Yastra AV's display. Instead, the LEA-100 applied a smarter approach. Its AI bundled all vital information: GPS location, tanker speed, wind patterns, and optimal strike timing into one minuscule data bundle. This got broadcast in a split-second pulse on the 433 MHz range, a frequency Russia seldom watches for UAV orders, then vanished. The strike group got the complete data package at once, possessing all they required for the strike to commence. This entire signal burst took only 0.5 seconds, far too brief for EREB AV to pinpoint origin, too scrambled for quick decryption, and sent via a channel Russian forces ignored. The Ukrainian strike unit had their marching orders. Ahead, the vulnerable bridge had packed 120 fuel tankers into single-file order, inching across fractured concrete and warped steel at merely 6 miles per hour. A shipment containing 1,000 tons of fuel crept forward like a sitting duck. If one tanker ignited on the span, the adjoining vehicles would catch fire, transforming the narrow passage into linked explosions and inferno. Ukraine had merely 8 minutes before the convoy crossed the bridge completely and separated. At precisely 0110:35 hours, the strike group sent the initial FPV wave. Each device featured a 10-inch carbon fiber frame, held a 7-pound shaped charge warhead, and had sufficient power for 7 minutes of flying. The route required 5 minutes travel. The numbers worked simply: 8 minutes open versus 5 minutes needed. Yet Russia wouldn't allow such a major convoy to move without protection. 3 defensive rings protected the crossing. The first layer demanded no conventional firepower: electronic warfare. Russia had learned a critical lesson from drone tactics. Destroying the machine matters less than cutting off control signals. Zero signal means zero command. Zero command causes system collapse, wrong direction, or automated retreat. Mission finished before operators see anything. Through the opening mile, everything operated perfectly. Ukrainian FPVs flew just 6 feet above Earth, using trees, ditches, and debris for shelter. The camera fed 1080p video at 60 frames per second, sharp images letting operators spot each hazard ahead. But Russia brought no optical surveillance tools. Moving alongside the convoy rolled a CAMZ truck, fitted with an R330 J. Hazel jamming apparatus. Picture a massive broadcast antenna working backward from normal communication. Instead of connecting devices, it flooded the region with electromagnetic noise. Once activated, JTEL showered GPS, GSM, and standard UAV bands with jamming signals. Picture an FPV operator talking into a handheld radio, while JTEL shrieks through thousands of boosted speakers at full volume. The signal pushed through. understanding did not. The screen jumped. Distortion stripes swept the picture. Frame rate fell from 60 frames per second to 30, then dropped to just 15. Picture quality sank to 2005-era mobile phone level. Yet FPVs weren't limited to single bands. Their adaptive radios jumped instantly across 124 distinct channels, while also switching into uncommon frequencies outside Huted's jamming coverage. Signal recovery happened, broken, late, fragile, yet enough for continued flight as the group penetrated further, setting down less than 1 mile from the bridge. Huted pushed jamming to maximum. The image froze, fractured into pixelated squares, then went black. Standard drone combat would have stopped here. These machines had backup guidance. When operator contact dropped, each FPV's onboard visual computer triggered instantly. AI began examining camera data, spotting fuel tanker shapes, bridge features, and stalled vehicle lines ahead. When targets came into focus sufficiently, the mechanism attached its aim to the center bridge tanker, steering the UAV for collision independent of ground commands. Huted could wreck operator sight. It couldn't erase guidance already installed in the aircraft. Now, each FPV found its way independently through the jamming barrage, refinding the bridge, holding target lock. Operators no longer ran the assault. Machines would finish it on their own. The monitor exhibited flight data alone: height 6 feet, forward speed 28 miles per hour, direction steady toward the bridge. Camera feed hadn't fully vanished under R330 assault. It fractured occasionally, displaying isolated frames before drowning in static once more. Those brief flickers mattered hugely. One frame showed highway marks. Their spacing put the bridge roughly 1.5 miles away, with convoy approximately 1 mile closer. Compass readings corrected the flight path. The FPV group came within 500 yards of autonomous targeting range. 0 workable images existed. No way to verify bridge position. The operations team made the choice to move the swarm another 500 yards into Hutel's jamming zone. 5 seconds afterward, the picture suddenly returned. The FPV wave had moved through the heaviest jamming area, though the group had drifted left of its original course. The bridge showed on the right screen edge, while fuel tankers continued their slow passage over damaged timbers. The AI began spotting targets. Simultaneously, Russian fighter UAVs descended at 75 feet altitude, dropping through foliage. Russian fighter craft plunged at 60-degree slopes. They held no warheads, allowing unrestricted mobility. Their sole job: hit with enough force to trigger the 7-pound opposing warhead. Ukrainian FPVs carried 10-inch carbon fiber frames. However, the shaped charge warhead raised overall heaviness considerably. After almost 4 minutes steady operation, battery strength had declined. Motors needed excessive force just to maintain 6 feet altitude. Forward thrust hit 80 miles per hour, but remaining capacity for quick speed boosts or dodges had vanished. Russian fighter craft, on the other hand, carried no explosives, providing superior power-to-mass ratios. Descending from 75 feet, they dropped and sped up together, altitude becoming velocity. 2 Russian UAVs attained 120 miles per hour. Ukrainian FPVs managed roughly 65 miles per hour. Joint closing velocity exceeded 180 miles per hour, surpassing 260 feet per second. From 500 yards, Ukrainian operators had less than 6 seconds to act. The operator dispersed the formation toward both flanks, but warhead-carrying FPVs slowed unexpectedly. Forward momentum kept pulling them, while battery exhaustion capped motor strength. At 100 yards, collision came near, under 1 second left. The pair Russian interceptors struck the front pair FPVs straight on. The collision detonated the 7-pound shaped charge warhead. A bright explosion flared 20 feet up, shattering the FPV into countless carbon and steel fragments. Yet those dual detonations revealed Russian strategy. Interceptor aircraft demanded total speed commitment. Once started, that dive couldn't change. Either the attack succeeded or ground impact occurred certainly. Ukrainians grasped that the 7-pound warhead gave an unanticipated edge. It made descent quicker. The subsequent interceptor cluster appeared 400 yards away. Dive started. 120 miles per hour thrust kicked in. Vector locked on succeeding FPVs. At 250 yards, Ukrainian operators didn't sidestep. They waited. Gap shrank to 150 yards. Just 1 second until contact. Right when Russian UAVs locked into their dive, Ukrainian operators killed the engines. Lift vanished. Warhead mass forced 15-foot immediate descent, under 1 second, vertical plunge, away from collision path. Russian aircraft pierced empty airspace seconds earlier, exceeding 110 miles per hour at only 25 feet altitude, gave no space for correction. One buried itself in a hillside, fragmenting. The other crashed next to the bridge, stopped cold. Yet killing throttle suddenly put Ukrainian FPVs in peril. Without thrust, they transformed from flying devices into heavy falling objects. Pushing throttle back too fast risked violent sideways rolling. Hesitating, even 1 second too long, guaranteed crashing. Luckily, Ukrainian groups had rehearsed this method dozens of training cycles. Thrust climbed slowly, gently, steadily, enabling propeller thrust to restart. FPVs shook hard, then leveled off descent to 8 feet height. Russia hadn't quit. Yet another interceptor group rose from the trees, gaining height for the next diving pass. Ukrainian operators understood that staying passive would mean losing drones one at a time until nothing reached the bridge. They chose action. Spring the trap first. The FPV group divided into pair formations. The initial segment surged to 120 miles per hour, racing straight at the convoy, appearing to launch the concluding strike phase. This immediately drew every Russian interceptor. They tilted, thrust forward, and chased the ascending craft. At the same time, the alternate segment slowed, descending to just 3 feet height. To Russian forces, these resembled battery-drained UAVs, broken formation, striking force exhausted. The snare performed flawlessly. Russian UAVs disregarded the low-level group, focusing complete power into forward chase, speeding toward the bridge. Yet holding separation required greatest engine force. Remaining battery offered about 45 added seconds of flying, insufficient for arriving at the target, intentionally. After 30 seconds chase with Russian interceptors completely withdrawn from bridge protection, the Ukrainian FPV swarm abruptly decelerated, executed sharp 180-degree turns, and charged backward. Formation closing speed reached 260 miles per hour. Russians took merely 2 seconds recognizing that chased craft had become flying bombs. Impacts ignited. Fireballs burst as Ukrainian 7-pound warheads erupted, obliterating Russian interceptor UAVs into scattered fragments. Within mere seconds, virtually whole formations dispersed into sky. From Russian defense perspective, stopping them appeared successful, yet they'd failed to account for the alternate group. The FPVs they dismissed as battery empty progressed quietly along the slope at 3 feet, advancing just 30 miles per hour, using hillside, plants, and shattered rock for concealment. The entire aerial engagement consumed 45 seconds. To survive and deceive Russian interceptor platforms, the surviving FPV contingent have exhausted nearly complete reserve capacity. Battery charge descended to merely 6%. Meanwhile, two-thirds the Russian convoy had already cleared the bridge. Fuel tankers remained compressed in extended column, crawling incrementally across fractured concrete and warped steel framework. Ukraine was losing temporal advantage. As bridge distance reduced to 500 yards, the FPVs abandoned embankment concealment, climbed to 45 feet, and initiated final assault phase at 120 miles per hour. Motors pushed maximum output, converting remaining electrical reserves into velocity. Yet at this battery condition, sufficient power existed for forward trajectory exclusively. Sharp banking, altitude adjustments, or evasive maneuvers risked voltage collapse below operational threshold. Motor cessation would follow, systems failing before convoy acquisition materialized. Yet Russians had prepared countermeasures. Escort personnel elevated Pichkal Pro and Stupor electromagnetic weapons from defensive positions. These projected directional jamming energy toward UAVs, disrupting command frequencies and impairing navigation capability. Theoretically, Pichkal Pro affects targets 5 miles distant. Combat reality demands direct UAV observation, antenna orientation precision, and sustained jamming beam contact. The leading FPV locked initially. Screen imagery froze. Control data evaporated. The UAV banked sharply leftward, altitude bled, trajectory crashed beside roadway. Yet, trailing drones continued. Upon detecting operator link interruption, their computer vision modules automatically activated autonomous AI functionality. Cameras searched bridge configurations, tanker silhouettes, engine heat emissions. AI locked target acquisition. From that instant, electromagnetic weapons could sever ground transmission, but couldn't override pre-programmed impact directives. Drones possessed target knowledge. Russian personnel transitioned toward primitive, time-tested defense methodology: rifle fire. From escort vehicles, troops advanced alongside bridge railings, raising AK-74s skyward, unleashing 5.45 times 39mm volleys into drone trajectories. Precision targeting was unnecessary. Objective involved creating bullet barriers directly before incoming formations. Convoy rear hosted soldiers carrying Vapor 12 shotguns, standing ready. Buckshot dispersed into lethal lead clouds, vastly superior against diminutive velocity-laden targets visible momentarily through sights. At 150 yards separation, the initial 75 rounds tore the formation. 3 connected. The leftmost FPV absorbed propeller damage, deforming individual blade. Lift asymmetry emerged, UAV tilting sideways, while flight controller increased alternative motor power, maintaining all together. The successive drone endured carbon fiber frame perforation. Structure remained intact, yet violent oscillation commenced at maximum velocity. The tertiary round proved most threatening. Battery casing penetration began voltage decline from 14.4 down to 13.1 within 2 seconds. Insufficient current supply accompanied maximum motor output. Camera feed darkened, propeller rotation diminished, altitude decreased incrementally. The FPV contingent possessed mere moments before losing flight capability. Yet ahead, Russian fuel tankers approached sufficient clarity for AI recognition on the bridge. The 3 surviving FPVs represented final hope reserves. Russian soldiers maintained fire, yet ballistic strikes paradoxically destabilized flight paths, complicating prediction. One banked sharply leftward, the second jerked vertically, descending rhythmically. The final oscillated violently through pierced battery housing. Neither maintained stable trajectory for accurate shooter leading. Within each platform, flight controller and AI processor continuously redistributed 3 motor thrust, preserving balance as battery voltage continued degradation. Distance compressed to merely 100 yards. Battery reserves reached 6%. The AI channeled complete remaining capacity into ultimate acceleration burst. 3 FPVs surged forward at 200 feet per second, even as propeller thrust diminished through voltage degradation below operation threshold. Inertia maintained target trajectory. Within 0.5 seconds, final 100 yards transited. They skimmed Russian soldier heads and descended toward fuel convoy below. Gunfire ceased instantaneously. Stray rounds threatened fuel tank penetration. Recognizing terminal opportunity vanishment, personnel retreated, seeking protective distance. Precisely at 01:10:42 hours local time, the inaugural FPV impacted tanker flank near bridge center. Its 7-pound shaped charge warhead detonated instantaneously. Metal penetration jet punctured tank shell, liberating fuel into dense vapor clouds. Less than 1 second post-detonation, fuel vapor intermixed with flame and ignited. A 60-ton wide fireball expanded upward from bridge decking. Central burn zone temperatures approached 1,000 degrees Celsius, warping thin steel components and incinerating surrounding vehicle paint. Flame columns shot beyond 100 feet altitude, trailing rolling black smoke 400 feet skyward. Pressure waves traversed bridge deck, obliterating windshields and launching loosened concrete fragments. The impacted tanker tilted dramatically, colliding with bridge infrastructure, completely obstructing passage. Before initial explosion completed, the secondary FPV arrived. It descended into the section where multiple tankers compressed together on the